Well, I guess we're at the end of the panel, and we're now moving on to, we have our 10-minute break, and our guest and host, who, let me look up, are Manuel and Martin. I haven't seen Martin. Am I did I not?
Martin's there.
He's here.
All right. I'm muted here.
What was the story about Martin? I didn't hear.
Martin, I think he just didn't have a picture and he's muted. Maybe
okay.
On my screen, he's a rightmost bottom.
Oh, okay. I
Ordered us.
Martin, can we ask to unmute?
Oh, we can unmute Martin. Should we do that as like I guess he has to unmute himself.
Hello?
There he is.
Now we hear you, Martin.
It was a bit
And you're
confused.
on the video.
In the discussion, sorry. Now I'm back. I should ask Hermano, right?
Yep. Or moderate other questions to Manuel, or answer.
Yeah, I prepared something.
I'm ready for you, Martin. For anybody.
We are not next to each other, yeah, due to these circumstances. How are you?
Very good.
Good question.
That was the simple.
Well, that was an easy one. I mean, I have to say.
The second one, actually, I wanted to ask you, and I think this was related to the discussion that was somehow also in the plan. Now everybody is talking about machine learning, and there's a huge industry interest, and we are sort of logic people, and Manuel is doing logic programming, I think, quite heavily. Will we still need it, or should we just stop with all that focus on collecting data and doing deep and reinforcement learning like the whole world? Or is there still some justification to use logic?
All right, I'll take it. I mean, I do know a little bit about learning and so on. I'm not an expert. I think that we should continue working on logic programming, and in fact, that gives me an opportunity to actually say, are we teaching people enough logic so that they don't forget about logic and logic programming? Because otherwise, you know, everybody will forget about it, and everybody will just be like, they will forget to program, because since the nets are going to program for us, then we don't have to learn to program. And then we'll discover that they cannot write all the programs, or at least for many decades, you will not be able to write the programs, and we'll have nobody that writes the programs. So that's the risk that the risk that I see coming. So we're in that topic. I mean, this question of should we teach logic programming or logic? Do I see students? Let me say at UPM, but of course it's in Europe and it's different and so on. But we teach a semester of formal logic in first year, and then in third year we teach a semester of logic and constraint programming, which I think is great. I mean, so the first semester we teach them propositional logic, circuits, natural deduction, whatever, and then first order logic and resolution. That's it. That's the semester. But we've learned a lot about how to do it. I mean, one thing is that we make it very hands-on. So for example, we use Z3. Everybody first year, you know, writes things, and then they do their natural deduction, and they check their proofs with Z3, and they see if it's, so it's kind of modern propositional logic is what I would say. I mean, so they get excited. And then for the logic programming part, we use ASP and Prolog. I mean, there will be a question of whether you want to use ASP also for the propositional part instead of SAT, which maybe posed to everybody. But for the other part, we use Chow, which has one thing that maybe people are not aware of, but that we have learned to add over the years so that we can teach logic programming properly, which is to have several. You can switch it to breadth first or iterative deepening or so on. And that solves the problem that people get very confused with Prolog at the first time, basically because they don't understand the trade-offs. But if you provide them the trade-offs, if they can write programs that you don't have to think anything, but they're incredibly inefficient and run breadth first, then they go iterative deepening, and okay, that's a bit better. I have to think about the bounds and so on over the depth. And then suddenly they realize that if I have a stack and I can backtrack and recover memory and so on, then I can solve really big problems with a little bit of effort. And they can move through this continuum wonderfully. We've learned how to do that. And then they come out, they really understand. And that brings me to maybe the last thing I wanted to say there in that sense. I mean, I really welcome opinions. Is I don't think a computer scientist is complete, or I think he's very incomplete if they don't know logic programming, because it is the only paradigm that is a little bit different between us. So it's incomplete. I mean, it's just not a real computer scientist, and this is happening. We have people. I won't give too much data because then it will be too close, and maybe you can guess. But people that are publishing papers all day in Popl and have no idea what Prolog or logic programming is. I mean, like no idea, like zero. I think that's it's unacceptable. I mean, I'm worried about them because I certainly understand functional programming. I understand imperative programming also. I mean, so people are missing so much. I think it's rather sad. Sorry, I already talked too much. So I know.
Thank you very much.
There are very good reasons, which Stuart Russell mentioned, that we know that these stimulus response networks, the so-called neural networks, brains don't work that way, by the way, will never be able to write these programs. But nevertheless, we are destined in this decade to create universal intelligent systems. It may be done in China because we are not making any progress. We have reached the cul-de-sac, right? And I think the answer for us with respect to these stimulus response classifiers is to incorporate them into our system. They make great peripherals, right? They deal with the raw data and they classify it, right? So let's use them, right, in our higher level abstractions. That is our defense. Make use of them. The problem is, if we're going to do that, we have to develop our own technology, right? We have to really up our game in terms of what we can do in abstract reasoning and robust inference. We can't for empirical things, we cannot maintain absolute consistency. So we can't be using classical logic for that. Classical logic is great for mathematics, but for empirical reasoning, you have to be able to tolerate inconsistencies. So we have to step up our game if we're going to do it. Otherwise, we get to follow the Chinese while they do it. Thank you.
So, Carl, I completely, absolutely agree with you. And I have to say, you're contradicting yourself a bit in the sense that the same way you were saying that logic programming or programming with logic has no concurrency and so on. I mean, one thing, you can have modules that are completely pure logic and you think absolutely logically, and then there's other modules where you interface with the world, there's nothing wrong with it. And then you represent it in the other module as a theory or whatever. That's no problem at all. So we have interfaces to machine learning systems, and you're absolutely right. This is the way to go. It's the way to go. It's just peripheral. I mean, you want to have vision, you have vision. You're going to have sensing in general. Yes, of course.
Manuel, I could say the world is multi-paradigm, right, Manuel?
Yeah, of course. Exactly.
But they're not top
paradigm language. Thank you, Peter.
The stimulus response networks are not top dog. We are top dog.
And I would say that, again, within the context of answer set programming, it actually allows you to reason with, you can have multiple worlds. So you can have inconsistent worlds exist at the same time. Right. And as humans, we do that all the time. We keep multiple heads in multiple. Oh yeah, mind, right? We see it in the news all the time, right, Gopal? Cognitive dissonance is everywhere in the news. Not just that. I mean, we usually have one set of rules for ourselves and another set of rules for other people, right? I mean, so we operate with that, and I think, and again, negation as failure answer programming actually allows a way to model that. And I think it's really a great advancement.
I forgot, by the way, that one of the things we're planning on using in class is SCASP, because I think it's great. We tend to use things that are a little bit integrated, so I don't have to learn a million systems, but SCASP is great because it goes so well after Prolog to explain negation and multiple worlds and so on. It's fantastic.
That's the system I mentioned, the predicate answer set programming. It's a collaboration between us and India.
Oh, I see. I don't know. Okay.
Yeah,
So that's predicate answer set programming in a query-driven manner. So you can actually have
top-down. It's top-down. Query. It's yeah. ASP in Prolog. I mean, in Prolog.
You mentioned this. Remind me. Actually, I see Adnan still here when he talk about these bottom-up, top-down building the compilation, and you're finding the repetition or caching the formula. That reminds me. I mean, David Warren, or where you're doing logic programming, you are all top-down, bottom-up, caching and removing redundancy, right? And just maybe didn't do in Boolean circuits or compiling the Boolean circuits, but it'd be really nice to make connection. In fact, there was one thing I saw Stuart left it, but really, I thought both Adnan and Stuart didn't do it yet in terms of, since you guys are talking about logic programming, is that they do for sure logic, right? They didn't do the recursion part. So the cyclic things, probably, I don't know.
Maybe we should move on. We're sort of at the end of the time.